Well, dear students, today actually I want to start here diffraction of light. But before studying the diffraction of light, we should first understand the meaning of diffraction. Diffraction is a common property of all waves, whether mechanical wave or electromagnetic wave. Then what is that? Bending of wave around the corner of the slit or obstacle come in the path is called diffraction. Common example of diffraction which we daily observe but don't notice what is happening. That is diffraction of sound is commonly observed. How? In every school there is single bell, and the sound of bell when it is rung reach every corner of every room of the school. So this is because of diffraction of sound waves. I am telling you the meaning of diffraction. People ask or tell in Hindi, what is the use of Hindi? When I am telling, okay, here I am teaching in this room, and you are getting lot of sound from outside. I am not still able to see the person or see the source of sound, and in every corner the sound goes. This bending of sound waves around the corner or the corner of the slit or obstacle in the path is called diffraction. In sound wave, it is very commonly observed. Light also has wave character. It has been proved by phenomena of interference. We have measured the wavelength, and that we notice there that wavelength of light varies from 4,000 angstrom to 7,000 angstrom. And average wavelength of light we have used as 6,000 nanometer. 6,000 angstrom. Now, why the diffraction of sound is so commonly observed? Diffraction of sound is so commonly observed. Why? Condition for this bending of sound wave around the corner of the edges of the obstacle or around the corner hole or slit is that the size of obstacle and wavelength should be close to each other. I explain you here this. Suppose it is a container in which water is filled. Water is filled there. My aim is first of all to make you clear what is diffraction. Actually, people are very much anxious to know about diffraction but unable to understand why diffraction. It is divided into two parts. Here is a narrow slit. A narrow opening here is there. Not narrow but some width is there. And in water, with the help of rod, we dip it again and again and produce circular ripples, which are called waves. So these ripples pass through this slit and spread in the hole. Whole water gets disturbed and waves spread in all directions here like this. It goes in all directions. I have told you concept of wavefront. The locus of point oscillating in same phase called wavefront. So these are the wavefront produced by the wave entering through this slit of water. Here is water and this. So these wavefront get spread in the hole. This bending of the wave produced in this part of the liquid is diffraction. Now if anyhow here it is another container having wide spread opening here, and here is water filled here, and again we produce circular ripples. The distance between two ripples, the circular or spherical wavefront here. In water we call the ripple. So wavelength, this distance represents wavelength. Now this opening is much larger than wavelength. So this way it does not spread in whole water. Bending is not so prominent as here. So condition of diffraction in bending of wave around the corner needs the condition that lambda and size of obstacle should be nearly of same size. Wavelength, size of wavelength and size of obstacle or the window or the door or any hole should be of the wavelength size. So simply this is called diffraction, bending. I told you very good example, sound. Whatever the sound is produced in any room or building, that goes in all rooms because of diffraction. But this is not commonly observed in light. If the light of my room goes off, then, and here comes a fault, then by using light of neighboring room, I cannot work here. Nothing will be visible. Why it is so? Because wavelength of light is of certain 1000 angstrom only. This come out to be equal to 7 × 10 to the power minus, 4 × 10 to the power minus 7 meter. Extremely small. But if the size of the slit becomes of this close to this, then bending of light can also not be neglected. I will be explaining in next video. Actually, I am making this short video just to explain you the meaning of diffraction. Without understanding the meaning, it is useless, it is worthless to study a topic. So I hope you have got what is diffraction. It is common property of waves, whether it is mechanical wave or electromagnetic wave. The diffraction is the common property of waves. We are listening sound from neighboring rooms or outside the building or outside the place where we are sitting without looking the source of sound because of diffraction of sound, wavelength of sound. Yes, you know, speed of sound nearly 332 meter per second at room temperature. At 0 degree centigrade. And at room temperature it is nearly 350 meter per second because it is room temperature. And frequency of sound is of the order of 100. That frequency of sound varies from 20 hertz to 2000 hertz, 20,000 audible sound. In general sound may be taken as frequency of 100 hertz, suppose. Then wavelength lambda C by n, C by nu, 332 upon 100, 23.32 meter. So this size of wavelength is much greater than the walls of the building or wall of the size of the door and windows. That's why now listen the sound coming from outside. It is because this fact. Wavelength size is much greater than the size of windows and doors. So I hope you have got me now. I will take in next video diffraction of light. Thank you.